Uh, if you please then, Dr. Moustafa, let's go to our next presentation, which is on the topic of more choices for connecting prefabricated bridge elements and systems. Again, Dr. Moustafa has the task of presenting this project. Please go ahead, Dr. Moustafa.
All right, thanks a lot, Armin. So this project is one of the serious projects that we have here at UNR, and it's collaboration with Professor Itani. Maybe because I rushed in the first presentation and I didn't acknowledge properly our research team here. So all these research collaboration, even though I'm leading this, but Dr. Itani is a central part of this project. So we have the PhD, a third actually, a fourth PhD student now have presented the work of several of them. So that's another PhD student who is working on investigating or looking into different options. So we agree that UHPC is a great material, and we have a lot of investment actually in UHPC research. But is this the only option? And this is the entire idea of this project. Are there alternative materials that can be used for ABC connections? So we started by focusing on the most popular ABC connection by far, which is using precast deck panels and the field joints that we use. So UHPC has been great. A lot of bridges around the country adopted this precast deck panels and used UHPC for the field joints. Now we are trying to investigate or look at different alternatives. So UHPC works, as we agree. It's just a little bit expensive on the material side. Not maybe a little bit. It depends on the application, of course. But the cost is one issue. The availability, we have great vendors in the U.S., but there are not too many. So some state duties have issues with bidding because you don't really have a lot of robust materials that you can go out there. So we wanted to identify and proof test potential alternatives. So we are looking in this project. We did actually, the objectives was to select alternative material and then characterize the material and mechanical properties of this material, and then showcase the performance of this material at a large scale, or actually it turned out to be a full scale test for precast deck panels and field joints. So we started by a literature, and probably for those who attended had the chance to see my presentation 6 months ago in the first research day for this year, we talked a little bit more about the literature search and the selection of the material. So today I'll just quickly go through this because I wanted to show more what we are doing now for the material and experimental testing. So we looked at different UHPC alternatives, and after a lot of search, we ended up testing or selecting polymer concrete as the showcase for this project. And there is a wide class of polymer concrete, same thing as UHPC. There are very large variation in the UHPC, proprietary versus non-proprietary. Same thing for polymer concrete. So we wanted to start with again, a robust material. We don't want to go with a non-proprietary material or anything, but we wanted to start with a robust material, and we used the Transport T17 for this. It has been out in the market, used in many projects around the country. So at least we know that we are not uncertain about the material, we are keeping the uncertainty to the large scale application which we are interested in. So we wanted to check that the material is robust in this regard. So we did also search on the experimental testing types, the connections, and we ended up choosing, these are just some of the connections that we looked at and the different types. And we ended up actually using one of the previous work that was done at the Federal Highway. So these are full-scale panel tests that were tested using UHPC for transverse and longitudinal connections, and we will be using very similar or identical dimensions so that we can compare with these tests. But we also are using our own UHPC reference connections as well, as I will mention in a couple of slides. So these actually are the desired features that were demonstrated by UHPC, and we are exploring if polymer concrete will be doing the same thing. So the material test, this is a major part. A lot of work has been done on material tests actually of polymer concrete in several universities. In all the universities in New Mexico, for example, they have a lot of work done on this. But we are just focusing or filling a gap in the literature, which we see in the direct tension test. So UHPC has been actually tested in direct tension for the last decade or two on the Federal Highway are like big on this. They tested like literally thousands of specimens. So there are some good procedures that are established. These are not ASTM standards yet, but it's a well-established procedure for direct tension material characterization. And for one-to-one comparison, we are doing the same thing for the T17 polymer concrete so that we can compare the tensile properties that we get with the typical UHPC tensile properties. So for this, we are doing the direct tension test, as I mentioned. So far, we have like a 60 specimen that we sampled, and we are using different parameters. This haven't been tested yet, but we are, again, in the process of testing them. We just started, so I will show results from one of the specimens that we just tested actually a week or two ago. So we have 3 different parameters that we are varying here. The shape of the specimen, and this is again dictated by the work that was done at the Federal Highway. So we have the dog bone specimen and the straight specimen. The polymer concrete got the option to be deployed or like used without aggregate or with like 3/8 aggregate. So we are testing both actually, the polymer concrete without and with the aggregate in direct tension, and we are varying the loading rate as well. There is a big polymer component, so this could be a rate-dependent material, and that's why we are testing under different loading rates. So that's the setup that we are using. We have tried it for the UHPC before, and we are using it again for the polymer concrete. This is just one sample of one of the tests, and we get like a clear crack in the middle that propagates and dictates the failure. And this is a typical behavior stress strain curve that we have been we got so far for one of these dogs like bone spur. So we tested 2 or 3, and we are expecting to test about like 50 more in the next few weeks. The second part of this project will be the large scale or the full program. And for this, we have again went through a lot of procedure to nail down the number of specimens, the shape, the scale, and all these things. So I'm jumping to the specimen details right away. We will do 5 tests, 3 transverse reinforcement and 2 longitudinal ones. So what you see in red here is the transverse reinforcement, joint, and what you see in blue is the longitudinal. And for every type of connection, we are using a polymer concrete and UHPC. Again, the idea is not, we are not promoting any commercial products here, but it's just looking at the broad behavior or the broad class of materials, polymer concrete versus UHPC in general, how they compare together and how they behave. But the idea is not to compare, one commercial product versus the other one or do any of these. I know this is a little bit sticky issue, so we are not going down this route to prefer one material over the other or give recommendation for one material over the other. It's just for pure fundamental behavior comparison. That's the objective here. And these are the 2 connection types that we are looking at, the shear key type and with a looped reinforcement and with a straight reinforcement. So we started, actually we built all the specimens. So the stage of the construction, we have the precast panels constructed separately. We align them and then we fill the joint with the material. So 3 stages basically. First, we construct the panels, we align them with the right dimension and the right connection for the field joints, and then we cast the UHPC or the polymer concrete for the joints. So I'll show some pictures from the construction. This is the first stage. We have 5 specimens, so we have a total of 10 deck panels, and these are the panels that you can see here, the reinforcement and the cast product, and some cylinders that we are sampling as well to get the strength of the panel, because it's not only the field connection. When we get a failure, we would like to see if the failure is in the joint or outside the joint, so we have to have a good understanding of the material inside and outside the joint. The second stage is, this is again for the first stage, but just some more close-up on the shear key. You can see here the shear key and the looped reinforcement, and these are all full scale. So just to note, this is 8-inch slabs for the transverse joints and 6-inch slabs for the longitudinal joints. The alignment, so we pick every part, or each specimen is 2 parts, so we pick the parts individually and align them so that we get the right distance for the joint and the right reinforcement alignment. Then we just finish the formwork and cast for the third stage, the filling material. So we did this with the UHPC. We cast the 2 UHPC sample specimens, and we are working on the polymer concrete ones as we are speaking. Honestly, actually, the student is out in the fab yard working on this. So in the next day or so, we will be done with pouring or casting the polymer concrete in the joints as well. So the setup that these will be tested at, it won't be a fatigue test. It will just be like a monotonic loading until failure. And again, the idea or the objective of the test is to see how the joints perform, the mode of failures, and how the different materials compare. So that's the loading setup that we have here. And what will be done next in the next few weeks is the test actually are expected to happen maybe early next year in January. And in a month or so, we will be providing some guidance on the effect of the material in the joint, how this can, or if there is an option to use something other than UHPC. This is what we will learn from this project. So we will summarize our results in a brief guideline, a 5-minute video that can summarize the project, something like a few slides with explanation, and a final report and peer-reviewed publications, of course. So this concludes my presentation, and I will be happy to pose for questions.
Thank you very much, Dr. Moustafa. We have actually a couple of questions on your presentation. First one asking, how do you see the cost of polymer concrete compared to UHPC? Can you give us a number, relative number or ratio?
Yeah, so for now, you know, like, as I said, like we are using commercial products just to understand the fundamental behavior of the material, but each of the materials, like if we are talking about the commercial products, they might have similar like cost, like similar cost, yeah, or they come with a similar price tag or close price tag. But the idea is that every commercial product represents a wide class of products. So every version, the same way you have the high-end UHPC, you could have like non-proprietary versions. Same thing for the polymer concrete, I assume. So the idea of this project is to investigate the behavior of a robust type or like a representative type of the material rather than just focusing on the code. So if, this might be actually a coming project in the ABC UTC, and I think this might be announced later on, but we will be looking into alternatives that will be cheaper, and the cost in this case will be the main focus of the project, is to optimize the material for these type of joints or other type of ABC connections with cost in mind. But in this project, the cost is not our objective, and that's why we didn't really care about picking a material that is cheaper or more expensive than the HPC. So the short answer to the question, I think they are both comparable in terms of the price for now.
Okay, that's reasonable. The next question is about the details that you used at the closure joint. Asking that, pointing out that looped bars
Yes.
for the closure strips are sometimes problematic in implementation or installation. Why did you choose this loop bar as one of your candidates?
So that's a very good question. So I mean, for construction, we didn't really see a big difference in the construction, but maybe this was in a small scale application. It only had 10 panels, so and only 2 of them got the loop. So it wasn't really a lot of work to do anyways. So I couldn't say something about the feasibility of the construction of these. But what I can say is that we talked about this type of specific connection with several DOTs, like Caltrans, for example, and they really prefer to see redundancy in these type of joints, because you know, if you have anything happens and any slippage, one of the rebars is not like sticking out to the right development links or so, at least this loop provides the redundancy when it brings the top and bottom rebars together. So it's more like safe, let's put it this way. And based on a very quick survey, not an official survey or anything, but just based on personal contacts with like several state DOT, several of them actually prefer to see at least one of the specimens with the loop in terms of the redundancy, and see how if this has really increased the strength or affect the mode of failure.
Okay, thank you very much. With this, we are at the end of time for this presentation.